Hey there, and welcome to a new YouTube video on the Future Programmer channel. In today's video, we're going to look at how we can create scatter plots using Python's Matplotlib package. Without further ado, let's go ahead and get started. Scatter plots are data visualizations that use points to illustrate the relationship between multiple variables. Each dot on a scatter plot corresponds to a value in the dataset. Let's import Matplotlib's pyplot module as PLT. Now we can use plt.scatter to draw scatter plots. Similar to plt.plot, we pass in a list for x and a list for y. Here we create x and y, which are the same function calls, numpy.random.normal, with a normal distribution centered at 0, with a standard deviation of 1, and with 750 values. We pass x and y into plt.scatter and show our graph using plt.show. And we can see our scatter plot on my screen right here. We can also compare two datasets using plt.scatter called multiple times. So we create a list of x and a list of y here, and then call plt.scatter, and do the same thing again. And we can see here our blue line, our blue scatter plot, is narrower in the y direction than our orange graph. And that's because the amount of noise we added is less for our blue dots than for our orange dots. You can take a look at the comments if you want to see exactly what I did for x and y. The advantage that plt.scatter has over plt.plot is that plt.scatter lets us customize attributes for each individual dot instead of for the entire dataset. Now, the graphs such as this one and this one can be very easily created with plt.plot. We have no reason to use plt.scatter. But what plt.scatter can do that plot cannot is changing the attributes for each individual dot. So not only can we change all of the orange dots to purple and all the blue dots to green, we can change this dot right here, very specific, this dot right here to purple, and we can increase its size or we can change its transparency. So that's what plt.scatter lets us do. We can change the color for a specific dot using the C parameter. The argument that we pass in is a list of values the same length as x and as y. So each color element in that list of C is going to correspond to a dot. So here we have x and y, and then we have a list of colors, red, green, and blue. We call plt.scatter xy with C being a list generated by random.choices colors k is equal to len x. So len x is going to be 100 in this case, so k is 100. That means this is going to be a list of 100 color values. This is going to be, let's say, it could be red, green, blue, 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 green, red, and then it will have 100 values of red, green, and blue. And after we call plt.scatter, we can see each of these dots is going to get a value in this list right here. This could be difficult to think about because they're just red, green, and blue anyway. But let's say we have a graph with only 3 points, 1, 1, 2, 2, and 3, 3. And let's say our colors that we pass as C is just red, green, and blue. That means the point at 1, 1 is going to be red, the point at 2, 2 is going to be green, and the point at 3, 3 is going to be blue. So that's how we pair up the x and y values with the colors. And as you'll see soon, it's the same thing with sizes. We can change the size of each individual dot using the s parameter, a list of sizes, with x and y again. And here we use list comprehension to create sizes, a list of values. So for each a and b in zip xy, so for each a, b in xy, we raise a to the fourth power, and we add that to b raised to the fourth power. And then we will pass sizes as s into plt.scatter. We create this plot right here, this scatter plot, and you can see immediately the dots get bigger as it gets farther away from the origin, from 0, 0. And that's because as a raised to the fourth power plus b raised to the fourth power gets bigger, the size gets bigger. So that's how we can use the s parameter to change the sizes of our dots in a scatter plot. The alpha parameter allows us to modify the degree of transparency of each individual dot, and it takes a value between 0 for transparent and 1 for not transparent, for opaque. So we have x and y, and we have a list of alpha. Alpha is equal to a list of random.random. This is going to generate a number between 0 and 1, and we'll have one such number for every value in x. And we can see our dots in this scatter plot all have varying degrees of transparency. You might expect that we can also change other things such as marker style, and you'd be correct. So here we have marker is equal to x, edge colors is equal to red, line widths is equal to 0.5. So we can see the proper adjustments have been made to our scatter plot. As a final scatter plot in this video, let's combine all of the customizations that we talked about into one scatter plot. We have the same dataset as before, but of course you can use other datasets that are not randomly generated normal distributions. We have sizes, which is a little bit different than before, but essentially the same thing. We have 0.05 plus a raised to the fourth plus b raised to the fourth for every x and y value. Colors this time, we have completely randomized our values, so we don't have red, green, and blue. Instead, we have random.random for red, random.random for blue, and for green, and random.random for blue. So this is a pair of RGB red, green, blue values. Now, interestingly, for Matplotlib, instead of 0 to 255, the RGB values are from 0 to 1. So that's why we call random.random. And we generate one such tuple for every value in x. Alphas is similar to before with one change, so we're using the max function to have essentially a floor at 0.25. So that's the minimum value that our alpha can be, 0.25. Anything less, and we may not be able to see the point properly, so that's why we have the max at 0.5, or the minimum in this case at 0.25. We call plt.scatter, x, y, c is equal to colors, s is equal to sizes, alpha is alphas, edge colors is another parameter that we can change as a list. So colors reversed. This is going to reverse colors. So if it was 1, 2, 3, now it's 3, 2, 1. And we call plt.show, and we can see a scatter plot right here. Now really the whole point of a scatter plot is we can show not just the parameters x and y, we can show more than just two variables. Now let's say, for example, we're showing a data set of people with their salary, and we have in the horizontal axis we have age, and in the vertical axis we have salary. Now using a scatter plot, we can show that perfectly fine, but we can also show the relationship between, let's say, the field that a person works at versus their salary. So we can change the colors of our dots depending on what field they work in. For example, software engineers have their points as blue, and let's say hardware engineers have their points as green. So we can show that. We can also change the sizes of our dots depending on how long a person has worked at their job. So the longer they've worked at a job, the larger their points. So we can show a lot more than just two variables using a scatter plot, and that's the whole purpose of using scatter plots. Hopefully this video makes sense for you, and now you know how to create scatter plots using Matplotlib. And that's it for this video on creating scatter plots using Python's Matplotlib package. If you have any questions, feel free to leave them in the comment section. And if you found this video to be helpful, please consider subscribing down below for more programming tutorials just like this one. With that said, thank you very much for watching, and I hope to see you in a future video.